Hello, we're Team B and we're going to talk about our final project. The team members of our team are Rene, Aarón, and Aneth. Introduction. The company we went to is Black Oak of Mexico. Right now, I'm going to talk a little bit about the history of this company. In 2001, Black Oak was founded as a joint venture between Black Oak Industries and Emerson Electric Corporation. 2 years later, in 2003, Kimco Group acquires 100% of the shares of Black Oak of Mexico. This means that Kimco Group became the owner of Black Oak Mexico. Later, in 2005, includes more value-added operation in its products, as machining, painting, heat treatment, and subassembly. In 2007, it incorporates lean manufacturing methodologies for process improvement. 3 years later, in 2010, strategic capital investments were made, which allowed to become a flexible foundry, and also Black Oak of Mexico became one of the most important foundry in Nuevo León. In 2013, the construction of the plant 2 of self-hardening molding begins, and a year later, in 2014, it was inaugurated. Location. Black Oak of Mexico is located in the southern part of Nuevo León, in Santa Catarina. Description. A resume about what you're going to see in this project is that the work that was carried out was the analysis of an operation that is done regularly in the industry Black Oak of Mexico. The purpose is to see how this risky operation is for workers and the injuries or CTDs that this can be caused. The results will be demonstrated using the rapid upper limb assessment method, and an improvement proposal will be given based on the final result. Black Oak is a specialist in the manufacture of components for trucks, medium and heavy work, tractors, and agricultural implements, heavy machinery, hydraulic components, among other industrial applications. Some of the products are housings, differentials, hubs, brackets, and differential housing, and so much more.
Methodology. The ergonomic tool used is ruler, which was created by Dr. Len McAdamney and the professor E. Nigel Carlett. This method was first published in 1993 by the magazine Applied Ergonomics. Ruler is a tool that evaluates the biomechanic posture weight in the body. It mainly focuses on the neck, torso, and upper limbs. The ruler method divides the body in two parts, Group A and Group B. Group A consists of arm, forearm, and wrist, and Group B, legs, torso, and neck.
I will quickly show the tables that were used to make the analysis. First, we have arm score. Then we have forearm, wrist score, the global scores of Group A, neck score, torso score, leg score, and global score of Group B. The final score.
Results. Evaluating the video we just saw, we got the results of the arm score, which is deflection over 90 degrees, which gave us a score of 4 points. And also, we added 1 point because the arms were abducted, which gave us a total of 5 points. Then we have the forearm score with over 100 degrees of flexion, which gave us 2 points on this score. Also, we added 1 point because the forearm passed the central line of the body, which gave us a total of 3 points. Then we have the grist score, where in the video we were able to see that the grist didn't got too flexioned or extended. That's why we selected the 2 points because the grist was between 0 and 15 degrees. We didn't add 1 point because the grist wasn't radial or cupidally deflected. We chose a score of 1 in the turn of the grist because there was a pronation and supination in a middle range, not at an extreme range. Then finally, to get the global score of Group A, based on the score we got on each movement, we'll get the number that represents the whole Group A. In the group of the arm, we got a score of 5. In the group of the forearm, we got a score of 3. In the grist, we got a 2, and in the grist turn, we had a score of 1, which means that the final score, the global score for the Group A, is 6. Following with the Group B, we have the neck score, where we saw in the video that the neck was extended, which gave us a total points of 4. We didn't add 1 point to this score because the neck wasn't rotated and there wasn't a side inclination. In the torso score, we chose an amount of 2 points because there was a flexion between 0 and 20 degrees in the video we just saw. We didn't add an extra point in this section because the torso wasn't twisted and there wasn't a side inclination of the torso, which means the total is 2 points. Then to be done with Group B, we finally got the leg score, where we chose an amount of 2 points because the feet weren't well supported. As we could see in the video, the person was jumping on one foot, and that's not the best way to do it. Then to get the final score, the global score for Group B, we have the same process as we did with the Group A. We choose the neck points, which were 4 points, the torso points, which were 2 points, the legs were 2 points, which give us a final score of 6 points for the Group B. And one of the final steps is to get the developed muscular activity type and the strength applied score of Group A and Group B. As we saw in the video, the person was doing sudden forces. That's why we chose 3 points for this score. And also, the person was doing this movement more than 4 times at a minute. So the score was added 1 point, which gave us a total of 4 points. Then to finally be done with this ruler method, we have the final score, which can be get with the global score of Group A and the global score of Group B. The global score from Group A was 6 and the global score from Group B was 6 also. And then to both of these global scores, we add the developed muscular activity type and strength applied score, which was 4 points. That makes a total of 10 points to each global score. Finally, with the analysis results, knowing the final score, we can choose the level of action to be taken in this situation provided by RULA. Since the final score was 7, urgent changes are required in this task. These changes will be provided in the next slides.
Discussion. Now, I'm going to talk about the improvement proposal. We know that according to the results of the analysis and observing the abrupt movement that the worker has to perform in order to lift the load, we recommend to implement an automatic pulley to carry out the lifting task in a better way. This will be good for the company in a short and a medium term to avoid risk and possible cumulative trauma disorders. Now, here we have the improvement proposal draw, and it helps us to understand the idea in a graphical way. At the top of the drawing, we have the pulley that is gonna help the worker to do his job easily. Eliminated risks. We know that with the automatic system implemented, the risks are going to be eliminated in some ways. Also, the worker will only have to move his finger to be able to manipulate the dangerous load, avoiding to make critical movements near to the risky load. Eliminated cumulative trauma disorders. We know that some of the benefits with the application of the improvement proposal are the cumulative trauma disorders eliminated, like tendonitis, that is caused by the repetition of a particular movement over time, thoracic outlet syndrome, that this occurs when the nerves or blood vessels below the neck are compressed, or the curvain tenosynovitis, that is caused by a particular movement day by day. Then we have the implementation cost. The team investigated a quote online with a provider, and we found this type of equipment available which fits into the budget and has the specification required for the performance of the task. The cost of the pulley is 13,700 pesos each one. Talking about the cost, also we need to talk about the installation and maintenance of the new machine. To carry out an implementation pilot at the workstation that was analyzed, it will be necessary to install two of these equipments, and the cost of this is going to be 27,400 pesos and an additional amount of 3,000 more by the cost of maintenance. This will be a total number of 30,400 pesos. Talking about monetary remuneration, we know that the 61% of occupational injuries are associated with repetitive movements, and the average cost per case are about 300,000 pesos. Black Hawk would only have to invest around 10% per year of the probable cost of one single CTD of any of its workers, and with this it will be able to reduce considerably the percentage of probability of developing some disease, just incurring only in the cost of purchase, installation, and maintenance of the new electric hoist winch. Here we have the current situation with a probable annual expenditure of 300,000 pesos and the proposed situation with a probable annual expenditure of 30,400 pesos. In organizations, nobody has the absolute truth of what will happen in the future. However, it is always necessary to implement and maintain the ideology of continuous improvement for the welfare of workers and the company. In the first instance, it seems that our improvement will only entail cost to the company. In spite of that, it is a proposal that will help the prevention of CTDs, which is clearly a latent problem that will affect both the workers and the company. That is why it is recommended to implement the new automatic pulley to reduce the risk of falling into the type of errors that brings very severe consequences. Thank you.